So my research area is called transcendental number theory, which is a branch of number theory.
Galileo once said that the universe is written in the language of mathematics. It was exciting to me to try and conceptualize transcendental numbers as a landscape that is only partially discovered. The painting that we developed together is named Transcendere. This painting shows a sort of universe of the language of mathematics.
In grade school, you start out learning about the counting numbers, and then you add in negative numbers, that gives you the integers, then fractions, that gives you the rational numbers, and then you get to polynomials. You're taking square roots and cube roots, and that leads you to the algebraic numbers. Beyond that are the transcendental numbers. Anything which is not the root of a polynomial is a transcendental number. So 99.9999% of all numbers are in fact transcendental. But that belies this incredibly difficult problem of proving that numbers are transcendental. It's just even difficult to write down a transcendental number sometimes. If you think about the number pi, right, it has an infinite non-repeating decimal. So how do you get your hands on that? I mean, you can't write it all down because it never stops.
Since we mostly can't prove these transcendental numbers, we only have an inkling that they may exist. So for me, this seemed like a similar conception of dark matter in the universe. We know that most of the universe is comprised of dark matter, but we have difficulty seeing it even with advanced tools and technology.
So if you imagine all the transcendental numbers as a big swath of canvas, the sets of transcendental numbers that we actually understand could be visualized as just a single line down the center of the canvas. That is how small the set of transcendental numbers is that we actually understand.
In the upper left-hand corner of the painting, kind of stretching diagonally across the composition, you see almost a Milky Way of pale shimmering inks and silver and gold equations written out in this area. And these represent those few numbers which are proven to be transcendental, one of which is actually Professor Nathan Green's equation that he's added to this landscape of knowledge. And then on the outskirts of that, the inks start to drift away, almost become invisible into the background. They're grays and blues and greens kind of emerging with the sky around them. And these are these possibly transcendental numbers. They're not proven, we're not sure. We think that they are, but they haven't yet been added to the canon. And then on the outskirts, you'll see these sort of very dark areas in which those few numbers which are proven to be non-transcendental exist.
One of the things about the nature of math research is just that it entails a lot of hard work, grinding hours of research, and in the thick of things, it's easy to lose track of that sense of wonder and discovery. Working with Grace on the painting really brought back for me that sense of awe and discovery of studying these transcendental numbers, these numbers that are so hard to pin down, and yet because of some of the work that I've been doing lately, we actually know that a couple more of these points of light are actually transcendental. So when I look at the painting, you know, I can pick out on the painting some of these bright shining stars, which are my numbers. You can't really own a number, right? But because of the work that I did, you know, we now know that these numbers are transcendental, and so we can write them with these shining gold inks on the painting.
Transcendere is the title of the painting that came out of this collaboration. Transcendere is a Latin word, and it actually means to climb up and over. It has this very physical sense of discovery to it. And to me, that made it a very useful word to title this painting, because the limits of human knowledge so often feel like an infinitely receding horizon to me, in the good sense, that no matter how far we traverse, over each pinnacle, we discover there's a vast landscape of new questions to approach that beyond the one we just answered.
For example, when you're trying to prove that one of these numbers is transcendental, you know, you try one approach and you work on it for a while and you see that it doesn't work. So you try another approach and you keep trying new things over and over and over again. And you do maybe 50 different approaches and you see that nothing you're trying works until finally you get the right approach. And then suddenly everything just clicks and it's smooth sailing from there. Once you know the right way to do it, everything just kind of flows and you're able to write down a proof and everything works out nicely. So looking back on research, you think, oh, why didn't I think of that in the first place? It was so easy, but there were the 50 different iterations you had to do in the first place to figure out the right way to do it. And that's where all the hard work comes in, is doing those iterations and figuring out what the right thing to do is.
In the process of making this painting, I did as I always try to do with my work, which is make the process of making match the conception that I'm trying to convey. So this painting itself is actually a collaboration. It's a collaboration between my hand-drawn ink work and the very precise CNC or computer numerical control machine drawings of the equations that are written upon them. In my studio, I have a robotic CNC machine, and I have taken the equations that Professor Nathan shared with me and translated these into computer files that my robotic drawing machine can read and then transcribe onto the painting. So over the course of a number of weeks spread out across months, this painting slowly built up in a collaborative relationship in layers between the equations that I'm placing and having drawn onto the surface with the machine, and then my more organic brushwork on top of that. And I think of this in a sense relative to how our messy human selves dance knowledge. We try to take the confusion, the abstraction of the world and make it concrete. We try to prove something is transcendental. And to do that is very precise work. And so it seemed to make a lot of sense to employ the use of this robotic drawing tool in the process.
So when Grace and I came together to talk about this, we formulated our idea about the analogy between transcendental number theory and space. And then as we started working on the project, I came up with a list of equations and symbols, both ones which we know are transcendental, the very few, and then the vast number that we conjecture to be transcendental. So I sent that list to her to incorporate in the painting.
I really appreciated Professor Nathan Green's patient explanations of his research. We met and he showed me on a whiteboard how some of the equations are proven to indicate that these numbers are in fact transcendental and not just possibly transcendental.
Mathematically, we'd say that almost all numbers are transcendental, and the proof of that is actually pretty straightforward. You can do a quick proof of that just using some counting arguments and drawing some pictures with lines and arrows going back and forth between different sets of numbers. So this very simple proof about the vast abundance of transcendental numbers contrasts with the difficulty of proving that any given number is transcendental.
And something that really became clear for me working on this project is how the acquisition of new knowledge in the humanities operates really differently than on the STEM side, and both are extremely valuable. What's really amazing is that Professor Nathan Green can add new knowledge to this ever-growing body of human knowledge regarding mathematics. And the humanities does something different. And I think it's also very exciting, but it's not about adding new knowledge per se. It's about recontextualizing ever-eternal truths, sort of human knowledge over generations, and trying to make that applicable for each new generation so that we can understand where we are in position to the bigger picture.
One thing that I hope this project accomplishes is that my math research is very, very detail intensive, and it's a little bit hard to tell people about it because of the amount of detail present. But this painting really distills that down into something very impactful and meaningful and visual and fun to look at. And as this painting is displayed permanently, I hope it conveys that sense of wonder and awe and fascination to the students and the public who view the painting. And I hope it inspires them to learn a little bit more about math and to become a little bit more curious about it and just to explore that in a new way.